Assalamu alaikum and good morning everyone. My name is Sayyid Anas Gilani and today I'll give you a brief video against chapter number 7 in which we discussed each example that was 7.1, 7.2, 7.3, 7.9, 11, 12, 17, 24, 25, 26, 27, 31 and 34. I would explain each code and I have made Proteus of some of them and I would show you and explain you in it. First of all, this is the Atmega 328P with which I have connected port B0 here and port C5 here. Which now this is the switch breaker for it. This is resistor 1 of 200. Then LED, this ground is extra, I would delete it. This is PB0, port B0, and this is the power supply here and power supply here. I would explain each code. I've written the codes. I've written the codes here in which I would tell you that what is happening in each example. This is example 7.1 here. This is the first of all in example 7.1 I would tell you int avr input output dot h. It is avr library. After it int main void, and then it is unsigned character. It is a counter variable. Then port b is declared to output, and loop 0 to 255 loop will work. This loop z is equal to 0 would work 0 to 255 as shown in the Proteus. Then after it, it is example no. Then after it, then Z send Z to port B. Then Z is sent to port B. Now example 7.2. In example 7.2 in start it is AVR library. Then program starts. Then character array is listed 0, 1, 2, 3, 4, 5 A B C D. Then it is unsigned character Z counter variable. Then port B is equal to output, like port B is initialized or selected as output. Then loop will work up to 10x as it would start from 0 and go till 10. Then this sends the character to port B. After it, the infinite loop is working and it will work till infinite. Then it is example 7.3. It is AVR library. The program starts. The port B is declared to the output, and it sets and port B is equal to 0 cross A. It sets alternating bits. After it, it is unsigned character Z, which is counter variable, and then loop is going to work 200x, like Z0 to 200. Then it is port B is equal to toggle port B, flip all bits. It will toggle the values of all bits, then while one infinite loop. Then it is example 7.9. AVR library, then CPU, set CPU speed, then delay library, then port B is declared as output, then increment port B and wait for 500 milliseconds. And then it is example 7.11. In example 7.11, AVR libraries, first of all, that is input output library. After it, port C is selected as input, DDRC is equal to 0. Then port B is selected as output. Then port D is also declared as output. Then there is a unsigned character temp. It is a temperature variable. Then it's a while one loop. Then read port C. Then check values sent to port B. Then after if statement that temperature is less than 100, then port B is equal to temperature, else port D is equal to temperature value, and return 0. After it is 7.12 example. Here in start AVR library, then all ports output like DDRB, DDRC, and DDRD. The three of them are declared as output. Then there is a AND operation. Port B is equal to 0 cross 35 and 0 cross 0F. This is AND operation. Then OR operation 0 cross 04 or 0 cross 68 in port C. Then in port D it is XOR operation. Then port B inverts the bits, like toggle is used and the loop will work infinite. Then it is example 7.17. Yes. Here in example 7.17, it is a switch case example in which in start it is AVR library, then temperature variable is here. No, sorry, not the temperature variable, but it is DDR0. Port B is an input, then port D is declared as output, then repeat forever. This loop will work forever. Then read port B, then mask the unused bit, then make decisions. Issues ASCII 0, then ASCII 1, then ASCII 2, and then ASCII 3. Now it comes example 7.24. Here AVR, here is in start it is AVR library, then bit 5, port B is equal to input, like bit 5, it shifts to bit 5, takes the and toggle it. Then DDRC or is equal to shift 1, shift 7, bit 7, port C is equal to output. Now after it, while loop 1 which were till infinite, then if pin B and 1 shift 5, it checks bit 5 in port B. Then port C or is equal to 1 shift 7, set bit 7 to port C as port C is equal to and toggle the bit value. This clears bit 7 port C and then return 0. Now comes 7.25 example. In it, it is the standard AVR header, then it is define LED 7, like LED is equal to bit 7, sensor is equal to bit 1. Then int main, sensor pin is equal to input, LED pin is equal to output, then reads the sensor pin, turn LED on, and if pin B and 1 shift sensor, port C is equal to 1 LED, else port C and LED turn off. Then it is example 7.26. AVR library, then temperature value is set, hex value is settled, ports is equal to output. These all the DDRB and DDRC is declared as output. X is my bit is equal to 05, mask upper 4 bits and get lower nibble. Then convert it to ASCII, then convert to ASCII, get upper nibble and shift right 4. Like the value is shifted 4 to the right. Then convert to ASCII again and then return 0. Then comes 7.27 example. In this example, first of all, it is AVR library, then BCD result is here byte, then ASCII 4, ASCII 7, unsigned character, then DDRB is equal to FF, port B is selected as output, then strip ASCII bit, then it is shift upper nibble, then shifts ASCII bit and combine BCD digits and send to port B. In W it is W is equal to W and 0 cross 0 if it strips ASCII bit. In 7.31 example, AVR library, digit variables, all ports output, then hex value 253, then divide by 10, 1 digit, then tens digit, 100 digits, send ones digits, and tens digits, and send 100 digits. Then in 7.34, first of all it is AVR library, then serial pin is equal to 3 here, then loop counter is here, then serial pin input, loop 8 bit, then shift right and shift right times 1 and then copy bits to MSB and infinite loop is working at the last. I would again show you the Proteus of the 7.1 in which we have connected the register and given it the value of 200. The switch is here which I turn on and off. This is the blue LED. PB0 is connected to this pin which is connected to PB0 in this 12 pin, and then in 20 it is the power is given here, and then here in PC5 it is this 28 value, and in 29 this is the power given here. The resistor here is connected to the power. Look, you can see here, and after it is connected to the ground with this switch, and then PC5, this is the pin which is connected PC5 here, port C5 here with 28, and then this 29 is connected to the power. So thank you so much for watching this video. I will explain the codes of example from 7.1 to 7.34. Just one port is explained. Thank you so much for watching this video.